Hello everyone. Today we are going to do this topic that is resistances working as voltage dividers. Voltage dividers would mean if I have a 9-volt battery and I want to divide this voltage into say a 3-volt component and a 6-volt component or a 1-volt component, how do I do the division? How do I divide them? So let us learn how things happen here. For resistance to be used as a voltage divider, we need to connect them in series. So when we connect them in series like this, let us say the upper resistance is called as R1, the lower resistance is called R2. Now you can find the voltage across these two resistances, or you could have it across these two resistances. In fact, I should be connecting the positive with positive. Let me just change this. So the positive should be connecting on the positive side of the resistance because that is actually going to be connected from there to the positive side, right? Here it will be connected. This is the positive side. So I'll keep this as the positive side and also this as the positive side. And this is going to be connected on the negative side. And this is black. Let us connect this here like this. So what is going to see the total voltage across from here to here is going to be 9 volts because it is actually the battery is 9 volts battery. But there is the voltage across this particular resistance and across this particular resistance, both these are going to be different. I'm not going to show you the total now, but we'll do some calculation first and then we'll figure out what. So this resistance is R1, which is 1K, and this is R2, which is 2K. I've kept them as small so that we could do calculations. All right. Now, uh, how do we calculate? This is the circuit diagram of the one that we had created just now. This is the source voltage, positive side, negative side. This is resistance R1, which is 1K, and this is R2, which is 2K. And we want to calculate across R2. We can also calculate across R1. I have set up the multimeter across that also. So we let us do the calculation across R2. The formula is like this. V out is basically the voltage out. That means voltage out across R2 or voltage out across R1 is equal to Vs, which is the source voltage, that is 9 volts, into R2, which is 2 volts, divided by R1 plus R2, that is 1 plus 2, which is 3. So, how are things going to be calculated now? Let us do the calculation. V, which is the source voltage, which is 9 volts, multiplied by, we are checking across R2, that is the lower one. So, lower one is 2 volts, uh, divided by, is it 2 volts? Is 2 ohms, yes. And R1 plus R2 is 1 plus 2, that is 3 ohms. Okay. So, 9 into 2 is 18. 18 divided by 3, which is equal to 6 volts. So, we will have voltage of 6 volts across R2. So, we have two resistances, one is the upper one and one is the lower one. So, if we check the voltage across the lower one, the voltage is going to be 6 volts. Alright. What happens if we check across the upper two? That means what is going to be here. Now, what changes we are going to make is this is going to change to R1 now. So, we multiplied by, because we are checking across R1, we'll put R1 on top and divide it by R1 plus R2 plus R2. So this is going to be 9 multiplied by R1, which is 1 ohms, 1 kilo ohms divided by 3. Okay, so this is 9 upon 3, which is 3 ohms, 3 volts. So this is going to be 3 volts in ohm. You will also find that the total of the voltages across all the divided resistances are going to be 9 volts. So 6 volts plus 3 volts is 9 volts, which is is the source voltage. Let us go across and see what is on our Tinkercad. So let's start the simulation, and we see the simulation. You will find that the voltage across the first one is actually 3 volts, and the lower one is actually 6 volts, and the total of these two is actually 9 volts, which is the source voltage. So the basic formula you saw, please note the basic formula. You can have it across the upper resistance or R1 or lower resistance, or you can have multiple resistances. For example, let us see multiple resistances. Alright. So if I have a third resistance here, okay, so I want it across this one also. So what will this be? This is R1, this is R2, and this is R3, and this is 1, 2, and 3 ohms, for example. So how am I going to calculate this? I'm going to calculate this as, for example, I want it across 3 volts, 3 this thing, so it will be 9 multiplied by 3, which is the resistance across which I want the thing. So this is 1 plus 2 plus 3 plus 3. So these are the three resistances. So 3 upon 6. So it is 9 into 3 upon 6 into 3 upon 6, which is going to be 1 upon 2, which is 4.5. So 4.5 volts is the voltage across the third one. Let us see whether it is actually what is the voltage that is going to be across. Let's bring in another resistance here. So I'll bring in another resistance here and connect this to over here and this with this, and bring in another multimeter and see how things happen. So I'll connect this to the negative side and this to the positive side. Color them properly. Let us see. Uh, this resistance is should be of 3 ohms. So you can see that this resistance is of 3 ohms, 3 kilo ohms. This is 2 kilo ohms. This is 1 kilo ohm. That is what we had decided on our formula thing also. And this is what we had calculated, 4.5 volts coming from your R3. So R3 is going to be your the lower one, and 4.5 volts is what is the voltage across this. Now you also will see that the total of all these voltages is again 9 volts. So for 4.5 plus 3 is 7.5, and this is 1.5, which is 9 volts. So voltage across the first one is now 1.5. This is now 3.0. This is now 4.5. These two have changed. Why? Because I have added another resistance to this particular system. When we normally use a voltage divider, we normally use two resistances only, but I can have multiple resistances. So we'll figure it out. Let us take a small example here to figure out how this voltage divider thing could be used. Okay, uh, What I've done is I've connected two resistances in series, and I want to connect a resistance or an LED in such a way that it does not get the full voltage. Although we have resistance here, but we need to figure out I need very less resistance, very less voltage at this point. So a node is connected to the positive side. Yes, I need to connect it to the positive side, and this is connected to the negative side. This is positive. How do I figure out what resistance should be there so that this particular part gets only 2 volts? So let's figure out the upper resistance is 1k. What is the lower resistance going to be so that this particular LED gets only 2 volts? Let me put a multimeter here to also check what voltage am I going to get from here. So this is the positive, so this is the negative connecting to the negative and positive connecting to the positive. So we check the voltage also. So what is the voltage the LED is going to get here? How do we calculate this? Let's say we just take this arbitrarily as of 100 kilowatts. What is this going to be? Now if I start the simulation, I'm getting 176 millivolts here. I want 2 volts to this LED. How do I do the calculation? Let me show you where you can do the calculation. I'll be putting the link of this website on into the description section, so you can check out from there. Okay, this is the page. I'll send you the link. If you don't want to do the calculation, you can do the calculation yourself. But there's a calculator supplied here, so you can specify what is the source voltage going to be. What is one of the resistance going to be? One of the resistance is 100 kilo ohms, so I have written 100 kilo ohms. What is the output voltage? Output voltage is 2 volts, because for the resistance, for the LED to work, I need maximum 2 volts. When I click on calculate, it automatically gives you what is going to be R2. R2 is going to be 28.571 ohms, or 28.571 kilo ohms. Sorry. So let us now check out. Let us now put this as what was the voltage that we checked here? 28.57. So 28.57, 28.57 kilo ohms. So when I start the simulation, you will find that this is giving you around 1.63 volts. So you can see that we can divide the voltage across resistances. By increasing or decreasing these voltages, we can change the voltage which goes across this particular resistance. Okay, we can do the calculations, and yes, the results here might come a little up or down, but basic idea you have received now. This is how we divide the voltage across resistances. Um, I hope this voltage dividing thing and the formula is clear to you. If you have any problem, you can put in those problems in the comment section. You can also give me suggestions. I'll see you in the next video. Bye bye.